What's up, guys? This is Jahangir from Midporium, and today we're going to be talking about how to calculate formal charge. So, calculating formal charge is really easy when you know the equation. So, the equation is going to be our valence electrons, and you can find these valence electrons just looking at the periodic table, and it correlates to which group. For example, if we're talking about oxygen is going to have 6 valence electrons because it's in group 6 or also group 16. Now it's going to be valence electrons minus our lone pair electrons. So any lone pairs we have in that specific atom. So lone pair electrons. And this is also going to be minus 1/2 of our bonding electrons. So bonding electrons. So this is our equation that we're going to use. It's going to be valence electrons minus lone pair electrons minus half of the bonding electrons, which are going to be just those bonds that we create, and only half of those electrons from that bond, which is usually going to be 1 if we have one bond. It's going to be 2 if we have a double bond, and so on. So let's look at an example to really illustrate formal charge. So I'm going to write the Lewis structure of nitromethane, which is going to be CH3NO2. So let's do this part over here, the carbon and the 3 hydrogens, which is the easy part. So we're going to have this carbon over here, then we have a hydrogen, and hydrogen over here. Then we're going to have a bond between that nitrogen. And here's where it might get complicated. So first we want to just write our bond of electrons over here, bond of that oxygen over here, just to write it down, and we can move on from there. So now we have to choose between putting a bond on this electron or this oxygen or that electron or oxygen. The reason why is because nitrogen has 5 valence electrons. So we need to fill in nitrogen's valence electrons while also fulfilling the octet rule. So if we, for example, put a bond over here, here's where the problem comes into play. So the only thing we could do is just put in our valence electrons for all of our oxygens. And this is where formal charge really comes into play. Because, well, first off, we filled these octet rules for this oxygen over here, this oxygen over here. We do have an extra valence electron over here, but as long as we fulfill that octet rule, then we're fine. Because this is the Lewis structure of nitromethane. And now, let's find our formal charges for each of these atoms. So hydrogen over here, and let's go with hydrogen first. So we have our equation above, and if we're looking at hydrogen, we have 1 valence electron, we have no lone pairs, and half of our bonding electron, so half of this, so that's half of 2, which is going to be 1, and that equals 0. So this is the same for all of our hydrogens. And now let's look at our carbon over here. So carbon has 4 valence electrons. So carbon has 4 valence electrons, and I'll just model it like this. And we're looking at half of our bonding electrons. So we have 8 bonding electrons. So because each of these lines represents 2 electrons, so this is going to be minus 1/2 of those 8 bonding electrons. Or you could also look at it as 1, 2, 3, 4. Because instead of think of it as half of the bonding electrons, you could just think of it as just one of the electrons in the bond. Either way, whatever works for you, that's how we're going to solve it. So this is going to be ending up being 0. So our formal charge for carbon is going to be 0. Now let's look at this nitrogen. So nitrogen over here is going to have 5 valence electrons, so we know that. We don't have any lone pairs, but we only have 1, 2, 3, 4. So we have 8 bonding electrons, or you could also say we have 1, 2, 3, 4. So 4 of those outside electrons, 4 of those bonding electrons. So this is going to be 5 minus 1/2 of 8, or you can also say that that's just 4, because either way you look at it, it really depends on what works best for you. Because if this definition of half of the bonding electrons works best for you, then go with that. But if you can just see that each of these sort of lines over here, the end of that line, it represents 1 electron, then all you have to do is count the end of each of those bars or each of those bonds to find out how many electrons you have, which I've seen has worked best for me. But like I said, it really depends on you. So this is 5 minus 4, which is going to be plus 1. So our nitrogen formal charge is going to be a positive 1. So now let's look at this oxygen over here. So in our periodic table, we're given oxygen, which is 6 valence electrons, and let's look at the lone pair electrons we have. How many electrons we have that are outside making these lone pair, which is going to be 4, so minus 4 electrons. And let's look at half of the bonding electrons, so that's just going to be 2. So this is minus 2. And this results in a 0 formal charge. Now let's look at this oxygen over here. Now, like we said, we're given 6 valence electrons, but over here, our lone pair electrons, we have 1, 2, 3, 4, 5, 6. We have 6 lone pair electrons, and half of this bonding electron is just 1 electron. So this is minus 1 electron, which gives us a negative 1 charge as a formal charge. So our formal charge for oxygen over here is going to be minus 1. So since both of these formal charges cancel out, our overall formal charge is going to be neutral. But if the question asked us, what is the formal charge for this oxygen on the bottom, or what's the formal charge of the nitrogen, then we'd write down what that formal charge is. Now, another way of looking at formal charge besides using this equation, and this might actually be easier for some of you guys, is the group number, because the group number is pretty much the valence electrons. So group number minus number of electrons that you see. So if we go by this equation, then we're pretty much looking at the same exact thing, just summarizing this equation over here, but we're looking at the amount of electrons we have. So oxygen, we have 1, 2, 3, 4, and then we're counting these as electrons, just one side of them. So this would be 5, 6. So the group number minus the total amount of electrons, that's how you get your formal charge. So if that still didn't make sense for you guys, don't worry, we're going to go through some more practice. So now let's look at ozone, which is O3, and we're going to have 3 oxygens, so obviously we need a bond to actually hold those oxygens, so I have a bond right there, just putting a bond. So let's start with this oxygen over here. So to fulfill that octet rule as well as the valence electrons, we need to at least add one more bond, so then we can create our general oxygen, which is going to be these 2 lone pairs and then these 2 bonds. So we filled the octet rule over here as well as our 6 valence electrons. So now let's look at this oxygen over here. Now the reason why we put our lone pair 2 electrons instead of another bond is that if we did put another bond here, then that would fill the octet rule, but we'd have only 4 valence electrons. So when we're looking at these Lewis structures, we want to get as close as we can to our valence electrons while still maintaining our octet rule. So there's no defined way of writing out your Lewis structures, because it really just comes with repetition and just experimenting, trying them out. So this one over here, where we have a lone pair, this is much closer to our 6 valence electrons. Although we still have 5 valence electrons, this is closer than if we had 4 valence electrons, like our past example. So this oxygen over here is going to have 1, 2, 3, 4, 5, 6, and then 7 valence electrons. Fulfills the octet rule, but we have an extra valence electron. Now, this is where formal charges come into play, so I want you guys to answer this question, and I want you guys to write down what's the formal charge of the top oxygen over here and the formal charge of that final oxygen to the right. All right, so let's start with this top oxygen over here. So what do we have? Well, we know we have 6 valence electrons from our group number, and let's count out the total amount of electrons that we have. So we have 1, 2, 3, 4, 5. 6 minus 5 is going to get us positive 1, and over here we're going to have 6 valence electrons minus 7 electrons, which is going to get us a minus 1 charge. So I was just using this equation over here, which is group number minus the number of electrons. And remember, when you're counting the number of electrons with these bonds, you're only counting one of those electrons, because these are shared, but if we're looking at the electrons pertaining to that element, it's only going to be one out of this bond, out of those 2. Now that's pretty much all for formal charge, because all you have to do is use these equations when writing out your Lewis structure. So get good at writing your Lewis structure and using the equations. Now hopefully you guys learned something, and as always, a Pomodoro a day will make you a doctor someday. I'll see you guys in the next one.